Hello guys, welcome to my channel. You're welcome to Master Builders Online Academy. A very online academy where you can learn all the tips as to how you can gain mastery to any calculation course at all. So guys, I'm super excited to appreciate every one of you who are subscribers to this channel. In fact, so many of you have become so addicted to this channel that a day will not go by without you visiting to check out our new update. We like what you guys are doing in this platform. Thank you so much. We appreciate you all. Thank you. We love you. Listen, this is a learning platform, and then we want to start looking at the basis of complex number. Remember, this is a continuation class. We have lesson 1, so if you have not watched that content, you can check our channel, so you can visit the playlist section and then check out for complex number. You'll be able to see previous videos made on this topic. All right, so without wasting much of our time, don't forget that there are policy or guiding principles that will help you maximize everything that we teach on this channel. One of these principles is that you should never, on no account, should you skip any part of this video. This is because every bit of this video are encrypted with principles that will help you gain mastery. So do not skip, because you may skip that particular section that would have helped you or enlighten your mind to know what to do to be able to get in full details of what we are about to do. So in this class, I'll be holding you by hand and teaching you exactly how to perform the basic operations in complex numbers. All right, guys, so I hope you have actually said that prayer. If you have not, please just skip it back so you can say that prayer and then you continue, because it will enlighten your mind to understand what I'm about to teach you very quickly. Now, as you can see on the board, we have operations of complex numbers. Operations of complex numbers. So when we say operation, we are actually talking about what are the basic tasks that we can actually carry out in complex number. What are the basic tasks, basic assignment? So these tasks are what are termed operations. So the operations of complex number include the following, and then we are going to be taking them one after the other. The first operation of complex number is addition of complex number. Addition of complex number. This is where you are able to add one complex number to another, whereby you can add real to the real part and then add imaginary part to the imaginary part. The second operation of complex number is the subtraction of complex numbers. Subtraction of complex numbers. This is another operation in complex number. This one gives you the opportunity to remove one complex number from another, and in performing this operation, you subtract real from real or subtract imaginary from imaginary components. So the third operation is the multiplication of complex numbers. Multiplication of complex number. In this wise, you are able to multiply one complex number by another. You are able to multiply one complex number by another. Then the fourth is the division of complex number. Number 4, division of complex number. In this wise, you can actually divide one or more complex numbers by another. So this is the ratio of one complex number to another. Then we have another operation which is called the polar form operation. Polar form. You can actually transform the complex number that you are given into its equivalent coordinate system property, whereby you are able to obtain the modulus, and as well you are able to obtain the argument, which is the angle between the complex number and its modulus. Then number 6 is the operation of the Euler form. Euler form. In this wise, it is an extension of the polar form. But the difference between the polar form and the Euler form is that the angle of polar forms are in degrees, while the angles of Euler form are in radian. And most importantly, the Euler form are expressed in an exponential function, while the polar form are expressed in trigonometrical functions. Then the number 7 operation in complex number is what we call the Argand diagrams. That you can represent multiple complex numbers in one quadrant or in one coordinate system. This is done. So we are going to be looking at this, all of this. Then the last but not the least, as far as this curriculum is concerned at this level, is the approach of the De Moivre's theory. De Moivre's theory in expanding complex numbers, or the De Moivre's theorem in approaching division of complex numbers. So number 1 is addition, number 2 is subtraction of complex number, number 3 is multiplication of complex number, number 4 is division of complex number, number 5 is polar form of complex number, number 6 is the Euler form of complex number, number 7 is the Argand diagram, the representation of complex numbers in coordinate system, and then the number 8 is the De Moivre's theory. So all of these things, we are going to be taking them one after the other without wasting much of our time. Let's dive into the first operation of complex numbers. All right, so we have addition and subtraction of complex numbers. All right, so like I did mention earlier, you can actually add 2 or more complex numbers together, and as well you can actually subtract 2 or more complex numbers together. Now, one of the things that you really need to understand about this addition and subtraction of complex number is this. A real number can be added to a real number, as well an imaginary number can be added to an imaginary number. So when you are performing the addition of complex number, you add the real part to the real part, and then add the imaginary part to the imaginary part. In the same vein, when you are dealing with subtraction of complex number, you subtract the real part from the real part, and then subtract the imaginary part from the imaginary part. This is just a simple law. Add real to real, subtract real from real, add imaginary to imaginary, and then subtract imaginary from imaginary. If this condition is understood, then let's look at the problem before us. Now, this is question number 3. Remember that is a continuation class. Then we are given that Z1 is equal to this, Z2 is equal to this, and then Z3 is equal to this. Now, what are the operations we are asked to perform? These are the operations. Number 1, find Z1 plus Z2, okay? Then Z1 plus Z3, Z2 plus Z3, Z1 plus Z2 plus Z3, adding all of these complex numbers together. Then removing Z1 from Z2, removing Z3 from Z2, removing Z1 from Z3, removing Z2 from Z3, Z1, and just like that. These are the basic operations like they have here. It's very, very simple to perform. Now, while solving these problems, there are 2 ways to solve these problems. You can solve these problems using 100 tens and unit approach, or tens and unit approach, or you can just solve it using linear method. What I mean is you can have tens unit 5, 6i, just like this, okay, and then you add. You can use this, but I believe that this is quite more for children, so we are going to be using the direct approach to have this done. All right, so you can do this way, but you don't need this heading, so you do it this way. Add this to this, subtract this from this, or as the case may be. That's how this is done. But as we're going to be solving this now, we are going to be following the professional approach of this. This is for KG students. Are you there? Now let's solve this. So the very first question, this is solution. The very first thing that we're asked to find is that Z1 plus Z2. And this is equivalent to, so in this position, we are going to place the value of Z1. Z1 was given to us as 3 plus 5i, then plus Z2 is minus 7 plus 3i. I have I3, you can call it 3i. Remember, I explained this concept from the very beginning. Okay? Now, this is what we have. All we just need to do now is to clear up the bracket, remove the bracket. And remember that removing bracket for addition does not actually affect any of the original signs. So, this is simply 3 plus 5i minus 3i. This is what we have. So, like we have it, you bring the real part to the real part, and then take the imaginary part to the imaginary part. So, we don't need to start wasting much of our time. 3 minus 7 will give us minus 4, and then 5 plus 3 will give us 8. Alright, so this is the answer to this very question. It's as simple as this. Then, Roman figure 2, we have Z1 plus Z3. Again, Z1 is 3 plus 5i plus Z3. As you can see, Z3 is 4 minus 3i. Again, we clear up the bracket. This will give us 3 plus 5i. Plus times this guy will give us 4. Plus times this will give us minus 3i. All we need to do again is to add imaginary to imaginary, then add real to real. So in this case, that the first real number is 3 and the next is plus 4. So 3 plus 4 will give us 7. And then 5 minus 3 will give us minus 2i. This is just the answer to this question. So when it is subtraction, you subtract. When it is addition, you add. It's just as simple as this. Then Roman figure 3, we have Z2 plus Z3. And as Z2 is this, minus 7 plus 3i. And then plus Z3 is this, 4 minus 3i. Of course, you can see it here. This is Z2, and then this is Z3. That's what we have here. So again, we remove the brackets. This will give us minus 7 plus 3i, then plus 4 minus 3i. Again, the real part, minus 7 plus 4. These are the real numbers here. Minus 7 plus 4 will give us minus 3. And then 3 minus 3. 3i minus 3i will give us 0. So this becomes the answer for this particular operation. Hope you understand that 3i minus 3i gives us 0. So that means for this particular question, the imaginary part not exists. Okay, now Roman figure 4. We have that Z1 plus Z2 plus Z3 all is equal to Z1 is equal to 3 plus 5i plus Z2 minus 7 plus 3i, and then Z3 is 4 minus 3i. It's as simple as this. All we just need to do is to remove the bracket, and then this will give us 3 plus 5i minus 7 plus 3i plus 4 minus 3i. So in the same way, we need to collate the real part, add them up, and then collate the imaginary part, add them up. Now, as you can see, 3 minus 7. Now, look at it. This is real part, real number, and real number. So 3 minus 7 is minus 4. And minus 4 plus 4 will give us 0. What we are talking about now, that this is 3 plus 4 minus 7. These are the real numbers there. So automatically that will give you 0. So it shows that for this case, the real part does not exist. Okay, otherwise you can simply put 0 if you want to do that. Therefore, the imaginary part, I have 5i plus 3i minus 3i. This guy and this guy cancel out, and then we have plus 5i. Our final answer here becomes 5i. This is as simple as we have it. Very simple. As simple as it is. Now, the next operation that we have here is to remove or subtract Z2 from Z1. So we have Z1 minus Z2. And what is our Z1? This is Z1, 3 plus 5i minus 7 plus 3i. So this is what we have. Remember, this is the minus that is in between Z1 and Z2. This is it here. All we just need to do now is to clear off the bracket. And then this will give us 3 plus 5i minus multiplied by. Remember, This is minus 1 in front of this bracket. So minus times minus will give us plus 7. And then minus times minus will give us minus plus minus multiplied by plus will give us minus 3. Ensure that you expand the bracket there. Okay? And then when we do this, 3 plus 7 will give us 10. And then 5 minus 3 will give us plus 2i. This is the answer to that particular question. It's as simple as it. So you find out that the addition and subtraction of complex numbers is just something very simple for you to do. You can do this very, very short. Okay? Now, then the next option, which this was V, and then this is VI. VI is Z2 minus Z3. And what's that Z2? Z2 is minus 7 plus 3i, then minus open bracket Z3. Z3 is 4 minus 3i. 4 minus 3i. And then, this is it. So by the time we clear off the brackets, we will have this as minus 7 plus 3i. Minus times plus will give us minus 4, and minus times minus will give us plus 3i. That's it. So for the real part, minus 7 minus 4 will give us minus 11. This you can get with the help of your calculator. Okay, so we have minus 11 plus 6i. 3i plus 3i will give us 6i. Real to real, imaginary to imaginary. Then Roman figure, this we have Z3 minus Z1. And now what's our Z3? Z3 is 4 minus 3i minus Z1 is 3 plus 5i. Again, we'll clear off the bracket. The first bracket, nothing happens to it, it remains the same. So I have minus 3i. Then minus times plus is minus 3, and minus times plus is minus 5i. As well as it. So real to real, imaginary to imaginary. So that 4 minus 3 will give us 1, as we have it here. And then minus 3 minus 5 will give us minus 8i. This is just all about that. Then question Roman figure 8, we have Z1 minus Z2 minus Z3. What's our Z1? Z1 is 3i plus 5i minus Z2 is minus 7 plus 3i. Then minus Z3 is 4 minus 3i. The same thing we are going to do is to remove the brackets. And then when we clear off the bracket, this is exactly the same as 3 plus 5i. Minus times minus will give us plus 7. And then minus times plus will give us minus 3i. Minus times plus is minus 4. And then minus times minus is plus 3i. We have gotten this. So again, we need to add up the real part and then add up the imaginary part. And as you can see now, this is real, and then real. So 3 plus 7 will give us 10. And then 10 minus 4 will give us 6. We have 6, that's the real part. Then for the imaginary, we have 5 minus 3 will give us 2i. And then 2i plus 3i will give us 5i. Otherwise, minus 3i plus 3i will cancel out, then we are left with 5i. It's as simple as this. Then we have plus 5i. This is it. Then lastly, we are quickly going to look at the last question that we have here. This is the last question that we have here. So let's quickly look at and do justice to this. So now we have Roman figure question number 9. Roman figure 9. We have 3z1 minus 2z2. What this means is that we have to multiply z1 by 3 and then multiply z2. So we have 3 into, what is z1? Z1 is 3 plus 5i, then minus 2 into z2 is minus 7 plus 3i. It's just as simple as that. So by the time we clear all the bracket, 3 multiplied by 3, we have 9, and then 3 multiplied by 5, we have 15i. minus 2 multiplied by minus 7, or negative 2 multiplied by negative 7, we have positive 14 plus 14. And then negative 2 multiplied by positive 3i, we have minus 6. Again, from this level, we just need to add imaginary part to imaginary part, and then the real part to real part. So from first with the real part, 9 plus 14, that would have given us 23. So that 23 as the real part. Then 15 minus 6 would have given us 9 plus 9. This is just the major operation in complex number as touching addition and subtraction of complex number. So we can add one complex number to another by simply adding the imaginary to the imaginary and then the real to the real, or we can simply subtract one complex number from another by simply subtracting the real from the real and then subtracting the imaginary from the imaginary. Now the next operation we are quickly going to dive in is the operation of multiplication of complex numbers.